reason wasn't working, so I had to re-upload it. But you should have links for all that. All right. So let's walk through. I'd say I know you just got to this lab, but let's walk through the first 2 or 3 because I think there's things you already know how to do. So 1, I want to note this is a csv.gz. So that means it's a gzipped CSV file. So it's a compressed CSV file. So although it's compressed, so it'll save space on your disk, especially for really large data sets, it's okay to just read that in straight into read_CSV. All right. So this code, read CSV, we've done that multiple times. But what do I have to do first before I can just use this command? What do I have to do? You have to read read our library. Exactly. So again, I'm hitting Command Enter to throw it over in the console over here. So 2 things. 1, this is just a message, right? So I don't think we went over this. It's just saying, hey, this is the data that was that I read in. This is the way I read it in, saying I read all of these as characters pretty much throughout the entire data set. So 1, we talked about yesterday. We did view tax. Some of these look like numbers, right? So depending on what they are, we are going to later change them into numeric variables, especially city tax and state tax. But because they have the dollar signs, R doesn't assume that they are numerics. So it says, I'm going to read it as a character. So how many addresses are there in this data set? So how can I just count in this data set? How can I get the number of rows, the dimensions? So dim's one way, right? So there's 237,963. What's another way? And row. Right? We could also take a single column out and take length. But again, if I do length on tax, that doesn't tell us what we think it does. When it's a data frame, it tells us the number of columns. Okay? So nrow or dim. What if I wanted something like, let's see. All right, let's go back to this viewer. Let's go back and view the data. What if I wanted to count, for example, the number of non-missing entries in city tax? So if I do table, it'll be way too many unique observations, right? So how do I test if something's missing? Is.na, right? Tax, city tax, right? So that'll give us logicals, trues, and falses, right? So I'll print out a whole bunch of them. So I can say sum to add them up. So what is this saying? What does that number represent? So we said, well, this one we said missing. This one we said missing. So there's 18,000 cases where we're missing the city tax paid on that property. Okay? Across the whole data set. And if we wanted to get the non-missing, we have to turn the trues and falses. Trues to falses, and so forth. So we're saying sum of the not missing values. So it's saying there's 219,000 non-missing data points, right? They have information for city tax. We could have also done, right, we knew nrow was this. That should give us the same exact answer. If we took the entire number of observations and subtracted off the number of missing values, right? Or how many the count of the missing values. All right. So we want the total or the sum of the city and state tax paid. But again, why can't we just do that? We'll try it. Try sum of city tax. Try to add it up. What do you get? So if you run sum of city tax, what does it say on your machine?
Error,
Object not found. What would it? So that means something wasn't read in. So if you spell city tax differently, so I would suggest doing tax $, hitting the tab, and then scrolling through just to make sure that the name is the same. So what I did was I said tax $, I hit the tab key, and these are the column names of that data set. So if I try to say sum of city tax, it's going to say invalid type because when we read it in, it didn't treat it as a number, it treats it as a character. That's because of those $signs. Okay, so what are we gonna have to do? So we need to make a numeric. We could try as that numeric, but let's try that. It says NA, so some of them were changed as NAs. Well, we already knew there was NAs. Let's say we take out the NAs. We get 0. That doesn't sound right. I know taxes aren't that low in Baltimore City. So what happens when we do this? Doesn't like the $sign. Because it says, hey, you have a $sign in there? I don't know how to change that. There's no like ignore option like there would be, for example, in Stata. You have to take off the $sign yourself. So what is the command we learned yesterday for strings to replace things? So it's str replace, right? But what do we say about the $sign? It's special. You have to use fixed if you're trying to remove the $sign, that actual symbol, right? So let's say we want to replace in tax, city tax, we want to replace the $sign, and we want to replace it with nothing, just an empty string. We want to remove it, right? So this is taking in the string, saying I want to replace this $sign, but I want you to exactly match it. I don't want you to do any fancy things with regular expressions and all that kind of stuff, and change it to nothing. So I'm just going to print out the head of that. Let's see what we get. Missing values are just going to say missing values, right? They were already missing to begin with. But these no longer have $signs in them. Now, once we've got it as a string without the $sign, then we can take it and say as.numeric. Right? I'm going to copy and paste these two together just to show you two different things. So these two commands do the same thing. Actually going to do this. So just to reiterate, how piping works. So I'm going to walk through this code. So again, it goes from the middle out. So it says city tax, replace $signs with nothing. Once we've already done that, make it numeric. This does the exact same thing. It's just presented in a different way. Take the city tax, pipe it into this function, replace the $sign with nothing. After you get that result, put that into the as.numeric function. Okay? I'm just going to put head around everything, just so we can. Sorry, don't worry about that warning. I don't know why that does that. So after I assigned it just randomly to X for now. I just set it to be something, just so it didn't print out everything. So I can say head of X. Now you see there's no quotes around these. They're not.
Do we have to write in something for the string replace to work?
Yes.
What do we need to read in?
So that is the string R package. So, okay. For now, starting out, I would suggest doing this. At the top of every script you have, reading in these three packages, for now. Right, until you know which package is from where, library all three of these. Read R for reading and writing data. dplyr for manipulations and filtering, string R for the string functions. We'll talk about two other packages, one for tidying data and one for plotting later that we'll add to this list. So at the top of your list, these three functions should give you the things you need to work with. And to note, if you write str underscore, you'll see all these, str underscore, I don't even think you have to hit tab. I think you just say str underscore and then wait a second. These start to come up. Notice these are a little different colors. They're not fuchsia or pink or whatever you want to call it. Those were for the columns of a data set. These are blue. These are functions. And they tell you which package they come in. Okay, so that's this thing over here. They're in the string R package. That being said, if you don't have that package loaded, right, it doesn't necessarily show you the ones from that package. Okay, yes?
So when we install some packages like
Mhm.
we have to command library each time we want to use that package, or
Yes. Yes. In the script, so once you restart R, so if you close out R and restart it, you have to put that in. So that's why you put it at the top of scripts. But for example, one of your scripts may be, I'm going to replace all the strings. You don't need the dplyr command. Like, you might not be using dplyr commands and stuff like that. So you might not need the library. Usually, there's no harm in putting many, many, many packages here, except it takes some time for some packages to load up. The only times where it is problematic is if there are some name clashes and stuff like that. So there is another package called plyr. Okay? That exists out there. This will come up, and this is a very important warning. You have loaded plyr after dplyr. This is likely to cause problems, and it will. So if you need functions from both, you should load this one first, then that one. So for example, if you're interacting with dplyr and you've already loaded it up, and you said, I want a function from plyr, which we aren't going to cover, then you have to restart R and then load this one, then that one. Because the order matters. Or you have to use that : thing if you want to say plyr summarize. And the reason I talk about plyr specifically is because it was the precursor to dplyr. So if you accidentally load that function in, if you accidentally load that package in, almost all the functions that we hold near and dear to our hearts that we've been using for the past couple days, those are not going to be calling the right ones. Right? There's a summarize function, there's a filter function, there's a mutate function, all that kind of stuff. So because I've just done this, it gave me that warning, I have to restart my R before kind of walking through the next steps. Restarting R, to be clear what I did, session, restart R, it restarts my R session, and I can now read in or library these packages back in. I have to read the data back in. All right. So again, what we want to do now, though, is we want to reassign this variable, right? We want to replace it in our data set. So I'm going to say tax equals tax. Oh, sorry, keep hitting the wrong keys. Mutate, because I want to replace a column. I'm going to say city tax is equal to this. So again, I'm using mutate here on this data set. I'm saying take this data set. I want to do some mutation. I want to do some changing to the data. I want to make a variable city tax. There's already one in there, so it's just going to replace that column. And what I want to do to it, I want to take the current variable city tax, take out the $, and make it numeric. So now, in the tax data set, this variable will now be a numeric. Yeah.
I thought mutate was for creating a column.
Mutate is for creating new columns or changing already existing columns. Right? So it's either generating new ones or replacing them. at the same time, either way. If there wasn't anything called city tax, I could do city tax 2, for example, right here. And that data set will have both city tax and city tax 2 if I did it that way. But because I made it the same name, it just replaced it. And I want to note something else. The pipe doesn't care. So the pipe isn't only for dplyr functions. The pipe is just saying if you want to do things in a row rather than from the inside out. So I could have taken this exact syntax here and put that here where I wanted to replace it. So I could have done, I'm just going to copy and paste it real quick. So I could have done this, or I could have done this. These are doing the exact, these are doing the exact same things. Just different ways of presenting it. Okay? But in this pipe, I'm piping a data set into the mutate function. In this set here, I'm piping this column into these functions. All right. Does that make sense? Or does this at least make sense? That we're replacing and then making numeric. So I'm gonna copy and paste this exact code because we're doing the same thing with state tax. Okay? So mutate can work on multiple variables. So I'm saying mutate this one and this one. Just replace it with the numeric versions. And now if I say sum tax, state tax, it'll probably still give me NAs because there are missing taxes. Now that I took out the NAs, now that this is numeric, I can add up all the state taxes. Okay? So one, when we read the data set in and had $, so we couldn't use it. Or we couldn't use that as a numeric. We had to take away the $, then we had to replace it. Okay. So how many properties are there in each ward? So somebody tell me the command we would do for that if we want to use table, for example. So it's table, and then what do I put in there? If I want to count, if I want to do a frequency table of each ward from the tax data set, we can use GroupBy, but let's look at the tax data set again. Okay, so there's multiple ward sections, property addresses. Right, so ward is a variable in there. So how do I use the table command? What am I putting in here?
You do tax, comma, and then variables that you.
Tax ward, right? So this is a frequency table of the wards. So let's try it with GroupBy. That's one way you can get the answer, in a table. So how do I, sorry. It's okay. Group it by what? Group it by ward. And let's try tally. So, if we look, Ward 1 has 6,000 observations, 6,613. Just a different way of getting it. So tally will do a frequency count.
So at this stage, the problem I always face is how to see all of this. I mean, it gives you a certain number of records that you can see.
Yes.
Yeah, it limits you. Is there no way that you can predict the setting?
There is a setting. I would either use view, right? So let's call this ward table. So you can see all the rows and do that. Does that make sense?
Yeah.
So you have you pretty much have to reassign it or assign it to something if you want to view it. You could wrap it completely in a view statement, but yeah. So assign it and then you view, and you can go up and down and left and right.
Is that second column name called N?
The second column name is called n.
So could you do by ward and then sum of N?
Oh, okay. So sorry. You would, yes, but you would use tally. Or sorry, you would not use tally. So tally is a specific command that does counts. Okay? If you want to sum, if you want to count the number of records, right? Same thing, grouped it by ward. You want to do an operation. In this case, that n function counts the number of rows. Okay? So we talked about this yesterday, but summarize can do a lot of things. It can summarize based on a measure, or like on some sort of number, right? So you want to take the mean length, the mean property tax, for example, which is what we're going to do in the next section. But if you want to do specifically counts, this n function is what you use. So these are exactly the same. Summarize is just more, allows you to do more things than just count. So tally is just kind of a shortcut. So given this command we just did up top, this summarization, it says what is the mean state tax per ward? So instead of the number of observations, what am I going to put in here? Okay, we'll call it mean. Let's call it mean state tax. I'm going to say mean, right? I'm going to put state tax in there. And let's say we want to view it.
So you don't have to do the N, A, and R.
Well, do we? So what do we get? We got all NAs. So we do.
Okay. Now that you have calculated this B,
Mhm.
I think the additional factor where her question really comes in was when she said part of the N. So how many words contributed to each of the N's?
So
Each of the means.
now, we don't just have we can summarize multiple things at the same time, so we can combine these two. So if we run this, let's view the table. We'll now have n and the mean, right? So we can now summarize multiple things, right? In summarize, you can do summaries of multiple things. We could have done the mean, the sum, the variance, the whatever we wanted to do. The 30th quantile of the state tax. Okay? So summarize can perform multiple operations. Right? What is the max? So let's copy and paste this again. So now we have the number of observations, the mean state tax, and we want the maximum amount still owed. So let's look at our data again. So amount due is the variable we want to work with. But what do you note about? What do you see on amount due? We see NAs and a dollar symbol. So we have to make this numeric if we want to do summations or anything like that. So again, up here, I'm going to take this command, and before we run this summarization, I'm going to say amount due, and I'm going to put it in there. So up above, amount due was a character. Now after I run this command, it'll be numeric, right? So now max amount due what command? So what function am I using? Not mean. So we're not doing sum necessarily. So if we wanted the sum of the amount due by ward, we would do sum. But we want the maximum. Right? So now we run that. Let's view it again. In our, sorry, that's viewing tax. I'll pop that back up. So now we have the number of observations. We have the mean state tax, and we have the maximum amount due for that, for each ward. Okay? So we've slowly built this up, right? But in 2 stages, we have to make sure things are numeric so we can perform these operations like mean and max and all that kind of stuff. We've done that with string replace and as that numeric, and now we have the table. Or now we've used GroupBy and summarize to put things together. So let's try this again. What is the 70th percentile of city and state tax paid by ward? So I'll call it Q75 city, Q75 state. So what function am I going to use to get the 75th percentile? Quantize. Again, we need to remove the NAs. I'm going to do the same thing here. Okay, so I say quantile, this variable, this is the quantile I want, 75th percentile, and I want to say make sure you remove the missings. Now if we look at ward table again, we see this is the third quartile for city and state tax. Okay. So let's do a box plot. So of the city tax on the y-axis, so let's say y equals city tax. Sorry, tax, city tax. X is, let's look at tax again for the principal residence. Sorry. Let's view tax. So let's take a look at it. So let's see. There's property ID, block, ward, section, property address, lot size, city tax, property address, whether it's a principal residence or not. So we're going to be using res code here. That is the variable we're going to put on the x-axis. There's some police districts, the neighborhood, the location, latitude and longitude, all that kind of stuff. So tax res code. Okay, let's do a table of that. So let's look at the help for BoxFlat, if you get some errors like that. So one, BoxFlat takes in, so let's look at the help files. So again, anytime you get an error with a function, it's usually good practice, unless you misspelled something or something's going wrong, to look at the help files. So BoxFlat can either take in X, right, and all these other options, or it can take in a formula, right? So we'll talk about formulas again a little bit more, but the idea is the way you specify it is y, the tilde, that's how you specify formulas, data equals tax. Now, why are they called formulas for the most part? Because when we specify models, for example, if I want to do a linear model of city tax on res code, which we're going to talk about tomorrow, that is the way you do it. LM for linear model, Y tilde X, and we'd put like X1 plus, you know, state tax X2 plus X3 and so on. All right, so we're going to go and get into the syntax a little bit more tomorrow, but the idea is a formula is Y on the left-hand side, a tilde, and then X. For the plotting functions, it's one Y and one X. For the modeling functions, you can do Y and a bunch of X's, as many as your data kind of makes sense for. Ah, what a beautiful plot, right? We see a line, right? These are costs. So some residents cost a lot of money in city and state tax. I don't know what that is. We can look it up. We'll look it up in a second. But give me some ideas on make this better. So we can remove those points. That's one way. But as you see here, this big dark line, it's pretty much saying like all these are outliers, right? So we can transform the data, right? Again, we could use square root, we could use log, we would use something that kind of spreads out the data a little bit better. Again, we're going to use log 10 because these are costs. That kind of makes the most sense. I'm going to zoom it in. So things that are not a principal residence on the log scale at least seem to have a different median than the principal residence. So this is about $1,000, right? This is about $1 million up here. So yeah. So really quickly, because that's an interesting case of that really, really, really high thing. I'm gonna go back to that plot. We're gonna jump back one plot. Somebody give me one way they'd be able to identify this really, really high point in their data. Okay, so what's the code for it? So how do we subset rows with dplyr? What's the function? All right, so let's list out the dplyr functions we've learned. So there's mutate, right? Changes variables. There is select. What does select do? Subsets columns. Arrange. What does arrange do? It reorders things. It sorts things. Filter. What does filter do? Filters the rows. So which one are we using? Filter. We're going to filter the tax. We can say something simple. City tax. Tax is greater than 1 million. I think that's 1 million. Nope, that's like 10 million. Oh, there's a bunch of them. I think that one was about 6 million. So this is the one case, table 1 by 16. Property address is 1525 Russell Street. I don't know if anyone knows what that is. I do not. We can look it up in a minute. What is it? Does anyone know that? The stadium? Maybe, yeah. Maybe the Marriott, yeah. So also really quickly note, another reason to use the pipe, here, let me pull this up. When I did it like this, totally fine way of doing this in Plier, or dplyr, 100% fine. When I do tax, and then, minimize my screen, no. If I do tax and then pipe, and I hit tab, that is when it shows me the column names. So piping in RStudio, that with dplyr commands will show you the column. If you just say, you know, filter tax whatever. So what I'm saying is here are the names. So I can say city tax is greater than 1E6. That is just a shorthand way of saying 1 million. 1 followed by 6 zeros. I want to say it's greater than 66, that's one way I'll do it. The piping allows me to do tab completion. Okay. So let's do this. Max city tax. Oh, sorry about that. Okay, back to what you were saying before. I wanted to give you an example on how to do this. City tax is equal to the maximum of city tax. We had to remove NAs. Before it didn't work because I didn't remove NAs. This came up as NA and said there's no records. Because again, filter will remove the NAs. So this is a way to get it to say which one is equal to the maximum city tax. Okay, so we did a computation from this variable, got the max, and did some sort of filtering operation on it. All right, we're going to run through these really briefly. All right, subset the data to only retain those houses that are principal residences. Which command subsets rows? Again, filter. Right, how many such houses are there? Right, instead of going through these, I'm going to look at, so you should have the lab key as well on the website. I'm going to scroll down to that. We did the quantiling, did the box plotting. Okay, a couple ways you can do it. You could filter. You can say res code is in%in, right? But this doesn't, so we could say is it a principal residence? That's one way to do it. It gives us logical trues or falses. We could have just done equal sign. Because we only have one thing to test against, it doesn't really matter which one you use. But if we have multiple things to test against this or this or this or this, we would use %in%.
What exactly does %in% do?
Okay, so the thing on the right-hand side is like a lookup table, like a list of things you want to check for. Okay, so this is usually something you specify. So let's say you want to filter it by these 5 IDs, right? The 5 IDs go on the right-hand side, right? So it's saying, is this, usually a variable, for example, in this list that you've set? What that will return is a logical vector as long as the thing is on the left, right? So what I mean is, let's do a couple examples. X, Y, Z. All right, this is, I'll call this LHS for left-hand side. Okay? LHS %in% X, right? LHS is length 3, right? Gives me trues when the thing on the left-hand side is equal to the thing on the right-hand side. So what %in% is, okay. This more or less, %in% does the same operation as this. This, is it equal to this, or is it equal to this, or is it equal to this? That's what %in% is useful. So you don't have to do or over and over and over again. So it's saying, is this in this list?
In this case, will it be very case sensitive?
Yes, it's exactly case sensitive. But it matters which side things are on. So if you said, is X in this vector, it's going to return as many elements that are on the left-hand side of this. And in this case, X is, there's only one of them, so it returns true. If I said, like, is X, so my vector is X and R, I want to check it against X, Y, Z, it gives me a vector of length 2 back. Okay? So it's saying, whatever's on the left-hand side of percent and percent, check it against the things on the right-hand side using ORs and give me logical back. Right, saying check, is it this or this or this? Okay, describe the distribution of property taxes with these residents. Use a HIS with certain breaks or plot the density. So again, I'm going to do, so we have to actually run this. So we did a log. So up here it says log 2. Let's make this bigger. Log 2. Pres city tax was 1. So we added 1 just so that 0 is still in there because we log transform. We log transformed because it was heavily skewed. This is the histogram. This is kind of the way it looks. All right, that's kind of one gist of your data. We could have done a BoxFlat. We could have done a quantile. We could also do a density. Say plot density of this. One thing it'll say, error. X contains missing values. So you can have missing values when you do hist, but you can't do it when you do density. And if we look at the help file for density, we see an na.rm equals false again. So we could say that to be true. Plot the density. So density estimates the density. Plots it. So this is a kernel density estimate, a smooth histogram kind of the data. So again, you see this huge tail on the right-hand side. All right. We're going to move to some of these other things a little bit later because they are, because we want to get into manipulation, but we will come back to these with the string manipulation. But it'll be covered a little bit in manipulating data today. All right. So again, today I'm going to go through, let's see, probably about 10 or 12 slides, and then we're going to jump to the first part of the lab, do about 5 to 10 slides, jump to the second part of the lab for manipulating data. So in this module, we're gonna talk about reshaping data, merging data, and again, just reiterate some of the things with grouping, GroupBy, and summarize. So we're going to go from wide to long or long to wide, and we're going to use merging data with some of the join functions. So we'll show you how to do some of the things in base R, but again, we're going to use some of these more modern techniques. So this is a new package coming up, new package that we haven't used yet called tidyr. So dplyr we've used to do data manipulations. Stringr we've used to use for string manipulations. Tidyr we're going to use to more or less reshape our data. Okay, so let's talk about exactly what wide and long format are. A lot of times, this is the way people think of wide and long. So, for example, if you have an ID, each row is one ID, multiple observations, for example, if this is longitudinal data or panel data or repeated measures data. A column represents a new visit, for example. Visit 1, visit 2, visit 3. That's the way the data is set up. Right? So a lot of people think this is the way of wide data. Long data, so it's also sometimes called, I think they call it fat, like fat or slim or fat or narrow. But wide or long is the way I usually describe it. So this is wide, right? So it's usually, again, one observation per row, and you have repeated measures on the columns. I generally never have longitudinal data like this, or at least I reformat it to a long format, and there are a lot of reasons why. Many times it's because I want to plot things longitudinally, and this is not the most amenable to doing that. So this is what I think of as long, multiple rows per observation. And right now I'm using ID as an observation. Observation can mean whatever unique identifier that may be. So it could be a unique identifier is country, county, and then some sort of residence, for example. Those three together make a key. Those three together make a unique observation, unique identifier, right? So although I'm saying ID, and in these cases I am using one variable, generally it can be more than one variable that represents one unit. Okay? So here ID is repeated 3 times, visit 1, 2, 3, these are the values. And data for ID 2, it's represented twice, visit 1 and 2, 5 and 6 are the values. Note, this has a missing data data point here for number 2, but it has to be in there. It has to exist because of the way the rectangular format. And here, missing data points, for example, if patient 2 or ID 2 was lost to follow-up or never completed visit 3, we just don't need a row for that. We can still have it, but we don't need it. The way I think of it, though, is data is wide or long with respect to a variable. Okay? So some data sets can have, it can be a data set long with respect to, for example, blood pressure measurements, and wide with respect to visits or something like that. So I'll show maybe an example or two of that. So we're going to be talking about, well, we are going to show this with this Charm City circulator data. Okay, so this is the data. So this is the ridership of the circulator in Baltimore City, which is a free bus that started around 2010. And so there are more or less 4 lines. So there is the orange line, the purple line, the green line, and they call it the banner line in this data set. So in this data we have a couple different things. We have boardings, we have the average, and we have alighting. So alighting is people getting off. So you get on with a boarding, you get off what they call a lighting, and then average is the average of those two. So I guess the system to count boardings and getting off isn't exactly perfect. So at least that's the way they do it, because these should always equal that, right? Unless somebody's sitting on the bus and never leaving. Right? Okay. And so we have it for multiple days, right? So if you thought of date, so this day being the unique identifier, it's wide, right? It's wide with respect to this. But we have repeated measures for each day of the week. So if date is your unique identifier, it is a wide data set. But if you're saying, I care about the day of the week, it's long. It's repeated measures over and over again. Okay, so third, remember, the package we use for dates is LubraDate, right? So we have dplyr for data manipulation, tidyr, which we're going to talk about for reshaping, LubraDate for dates, stringr for strings. So again, I'm just doing some cursory checks on the data, just to give you an example of something you might do when you're reading a data set. Say how many of them are missing. Is.na date, we say 0. If the date was just an empty string, let's see if we count those. Some of those, 0. So every single row has a date, or has something in that date field. So we're going to say, sir, we're going to reassign it, mutate it, date. We're going to reassign date, so we're using mutate again to reassign a variable, not create a new one. And that's equal to mdy date. And yesterday we talked about LubraDate, so mdy will take in a date that it assumes to be month, day, year format. And the nice thing about it, in this data set, it's separated by slashes. If it was separated by dashes or spaces or something like that, that would be totally okay. So this, we've converted a date, but we want to be sure that everything went fine because we knew data was in every single cell. So we say sum is.na date again. So say after you've converted it to a date, was anything converted to missing? Were any of the dates not converted correctly? That's what we're checking here. If the answer is 0, good. We had data before, we have data here, it was converted. So let's look at the data. Okay, again, we see quotes around this stuff. We do see it as in a different format, right? Before it had slashes, here it has dashes. Again, it's not 100% clear to see that this is a date object after you convert it. It looks still like a character, but it is a date. It has been converted to a different format. Okay, so reshaping command data in R. There is a reshape command in R. Do not use it. It is hard. It is confusing. It tries to do too many things at once. It tries to give you 2 functions to reshape things wide and long at the same time. Don't use it. tidyr allows you to tidy your data. This is what we're going to be using for reshaping our data. And the 2 main functions that we're going to use are gather and spread. Gather takes multiple columns and puts it into a variable. So this is the thing. You gather up columns to make them data. Okay, so gather is for reshaping wide to long. Spread takes a variable and spreads it out across your columns Spread is used for really converting long to wide data sets. We're going to also talk about separate and unite. So separate, if you have multiple columns that you want to paste together into one new column, you use separate. Right? We could have used string operations, but this is a tidy, helpful tool to take things and put it together. Unite, unite brings things together. Separate splits them apart. So instead of using string split like we did yesterday, if you have things that are in a specified format, like if you say, let's say it was id.1 for visit 1, id.2 for visit 2, for example, right? And you wanted to separate those out to be a column of IDs and then a column of visit 1, 2, 3, 4. Separate is what you'd use. If you had two columns, ID and visit, you can join them together with unite. Okay, so gather puts column data into rows, right? So it takes columns, more or less transposes it, puts them into rows. So remember, we had multiple columns for green, purple, orange lines, and boardings and lightings. So we want to take that and convert it into a different type of data set. So what we're going to do, we're going to use the gather command. We're going to load up our functions in tidyr. Use the gather command, put in the data set, and then the two arguments that you put in are what do you want the new variable to be, okay? And what do you want the value of that variable to be called? Sorry, what do you want the new variable to be called that takes the values from those columns? So remember, purple A lightings, orange A lightings, orange boardings, all that. Those are the columns. So when we convert it, there's going to be a column that's a new variable that says this is the column that we converted. And now it's saying, what do you want to call the actual data in there? So key and value are the two main arguments that gather take, right? So this for stata is like ij, right, in reshape. The other thing is you have to specify which columns you want to gather up. So you can do that one of two ways. You can say, I want to gather these specific columns, right, in the same way we use the select commands, or I want to gather all these columns except for a few, and that's what we're doing here. I don't want to gather up day. That's not a variable data. I want to transform. I don't want to gather up dates, and I actually don't care about the daily ridership. We're going to remove that column completely because I only care about the purple, the green, the orange, and the banner, boardings, and lightings. Okay, so this will convert it to a long format, and we're going to go through this in a second. We're going to go through, let's read this data in. I want to do some tabulations. Okay, let me go back. So we now made it long. So now all those columns, all those column names are put into the var variable. And again, var is not special. Var we chose. Right? In the gather command, we said, I want you to call this column var. So if I table them up, now we see there's 1,146 observations for when it's a banner A lighting, banner average, banner boardings, so on and so forth. Okay? So now the data is long. And we see number was a column name that we chose. Right? So it made two new columns, and it removed all those other columns and put them into data. Right? So it transposed it and transformed it. Yes?
Why is it -D? Why is it minus?
So I don't want to gather those up. Right? So on the next slide, we could have been explicit and say, instead of saying I gather everything but these columns, right? I could have said that, which I did on the last slide, or this one where we say I want to gather anything that starts with the word orange, anything that starts with the word purple, anything that starts with the word green, anything that starts with the word banner. Two different ways to do the same operation. It's just one is saying gather everything but these. The other way is saying explicitly gather these specific columns. Yes?
When you choose the columns, can you use regular expressions or wildcards?
So you can with these special functions like starts with and matches and stuff like that. If you you do the help file for starts with, it's those dplyr helper functions that you can use with select, for example. So yes. All right, so two different ways to do something similar, but they're different thinking, and sometimes one is way more efficient. To say like everything is data except for these 3 columns, that's the way you do it, versus saying, you know, I don't want you to touch anything but these specific columns. These are the ones I want to take from wide to long. Like that data set we showed before, the visit 1, visit 2, visit 3. If I had, for example, demographic information alongside with that longitudinal data, I don't want you to touch the demographic information. Just take anything that starts with visit, for example. That would be an example where it might make a lot more sense to you to say explicitly gather these up versus gather everything but these. Okay, so we've learned a little bit about gather. Let's go to the lab. Lab for manipulating data, part 1.
The Y was long. I submitted 4 requests. That's the first part. Read in, confidentially, blah, 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 that was actually long.
Okay, got it. All right, so we should be going to the lab now. Give me 1 second for changing one of the data sets. Are you sure about that? I double checked that. The code ran with it though when you ran the key? Okay, perfect. Thank you for that. All right, so the lab and the key are up there, but I would say let's start just with the lab. We're only doing part 1 right now. So the first 2 questions. All right, so was everyone able to read in the data? Okay. So what am I using here? Read CSV. So who got gather to work? Okay. Who hasn't gotten gather to work? What's going on? Yeah. So if it says library and it says package not found, you have to install that library, right? So again, you have to run these commands up here, right, to read in the tidyr package. Otherwise, gather isn't a function that's available. So you have to use install.packages or tidyr, ggplot2, stringr, and ggplot2 we'll be using later. Yes?
You have a different font in your windows than we have in here. I'm having a hard time seeing the difference between the lowercase b, u,
Yes.
and uppercase.
Can you go to, I think, preferences, or if you go to tools, global options, these should pop up. And then you can look at your code. And I think it's, appearance. Sorry. If you go to appearance, you can change the fonts around to be whatever you want. And I have Monaco. That's what I use on. All right, that was the default for us.
I don't think that's a choice.
Yeah, it's a Windows Mac font fun thing. So yeah, you might have to experiment with a few. All right. So somebody not looking at the key, tell me how you gathered your data.
Gather, and then parentheses wide, comma, key equals lane type, quotes, comma, value equals underscore length, quotes, comma, minus name.
Yep. So this function will work if you put it in quotes or not. You can put it in quotes, and I think that's totally valid to do. That's probably the way I would do it. So long gives this data back. I said note the NAs. So let's view long. We'll come back to that code in a minute. So you see a whole bunch of NAs and then some data. A whole bunch of NAs and then some data. So if you view wide, we'll see why that's the case. So for example, Alice Ann Street has only a shallow bike lane type, right? But when we reshape this data, it'll repeat, for example, this over and over, or it'll have NAs for where, there's NAs in this data set. But we have to keep these NAs in our data set because we can't just throw out this specific NA without throwing out the entire row. Can't throw out this specific NA without throwing out the entire column. Right? But it's not applicable. Alisana doesn't have a bike boulevard, so there's no length to that bike boulevard. And here, they have missing values here, and now we can do filtering to remove them. All right, so again, we gathered the data set. We said this is the new column I want to make. This is the new column I want to make that actually has the data. And then it says drop the name. I want to gather all the columns but the name column. Okay? Yes?
There's a lot of variables that you want to manipulate. It's like it's,
So that's why you use starts with, or so in other languages you use, for example, Stata, you say something like variable name star, but that's why you use, for example, starts with, or some of these other helper functions if you want to reshape, right? If you want to grab multiple columns, right? Because otherwise in SAS I don't know how you do it with asterisks or something.
well, use prop transfers. Say you want to do everything in the data set. You don't even have to name it. You don't have to say which variables.
So you don't have to name it. So if you wanted all of them to be transposed, you would just not put anything.
Oh, okay.
So here, but look what happens when we do that. If you don't put that name, it says, all right, name is a variable. So let me do the head of long and tail of long. One sec. If we didn't remove name from the columns we wanted to gather, it's going to say, okay, name has data in it you want to transform and transpose. So what it'll do is it'll say, okay, it'll take all the variables, put them all in lane type, and whatever was inside those variables, it'll put in the length. That's fine, but that's probably not what you want to do because all the other columns represent a length of a lane, and name represents the name of that lane. Right? So you want to say, so pretty much a lot of times, what you want to put in here are variables that are usually, actual data that you do not want to gather up, and also ID variables, right? Or if you want to gather all the columns, and they all usually are of the same type, you just want to remove the ID variables and say these are not ones we want to gather. We want to keep those as is. Right, and like I said, so like in Stata or something like that, if you had a variable, if you had a naming convention that was like v1, v2, v3, v4, v5, v6, v7, and all that kind of stuff, and you would say v star, you would say starts underscore with, and then you just say the letter v. Right. All right. So now, we got some long data. Okay. So now we got the data set. We have those data in long format. So we don't want it to be called, let me go back. Like we've done the table before. We said banner A lightings, banner average, banner boardings. Right, let's say we want to put a period between the two so we can later separate them out. So here, we're taking in that data set, we're mutating it, we're just changing this variable around. We're going to say, whenever you see the word board, put period board. Whenever you see a light, put period a light. Whenever you see average, put period average. So now, that variable, whenever it saw a lighting, whenever it saw average, it just put a period between that and the thing before it. Okay, so it replaced the word board with a period, then the word board. Okay? This is because we are going to separate these columns, we are going to reshape it again and separate the columns out. So, separate will split a column into multiple columns based on a separator. Based on something to break them up on. So you remember in string split, we had a string and we said, what do you want to split it on? Same thing here. So we say long. We want to split up the variable column. Sorry, the column called var that we named. What do you want to split it into? The first column we're going to call line. The second column we're going to call type. Remember, it's purple dot boardings, purple dot a lightings, purple dot average. So the first columns, the first variable we specify here is going to be purple, 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 orange, 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 green, 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 banner, banner, banner. The type is going to be average a lightings or boardings because it goes purple dot boardings, purple dot a lightings. So it's going to split those into two different columns. And then we specify the separator. We could have used underscores, right? We could have gone back and said, change this to underscore a light, underscore board, underscore average, right? We just chose periods. And then whatever we chose, that would be the separator that we use here. I chose periods to show you that sometimes you have things separated by periods. And remember, periods are special. This is another way you can say, I want you to match periods exactly and split them out. So separate takes its variable, splits it up. So remember, let me go back. We had it where this variable is orange boardings, and we had a column named var. After this operation, we no longer have the column var. We split it into orange. We split it into line and type. Yes?
Is it the bracket or the quote that lets it know?
The bracket.
The bracket.
The bracket. That it knows that match this specifically. Right? So if we use unique, it's orange, purple, green, and banner for the line, and it's unique for the types of boardings, lightings, and average. So again, this data has repeated measures by line for the same day. So what we don't actually want this data to be lumped together for boardings, lightings, and average. What we want to do is now separate that out. We want to make it so one column for averages, one column for lightings, one column for boardings, separated by each line. So just like separate breaks columns apart, unite will paste them together if you want. So it's just the opposite. So there's separation. You have a column, break it into multiple ones. Unite says, give me multiple columns, put them together with a separator. Okay. So if we said long, and we wanted to make a new column, the column is var. That's the new name. So I call it the exact same thing it was before. What do I want to paste together? What do I want to put together? Line and type. And I want it to be separated by periods. And this would be the way it would give it back. So separate breaks things up. Unite puts them back together into one column, pasted together by a separator. You could have also used paste or paste 0 explicitly. This is just kind of a wholesale way where if you want to just paste columns together, because that's an operation you usually want to do. If you have a separator, you want to make multiple columns, or you have something and you want to join them together. I'm going to let me see. So part 2, we're doing uniting and separating. So this is some different data, some road data sets and some crash data sets online. So we're gonna jump to the lab and do 4, 5, and 6. 4, 5, 6, and 7 for part 2. So we're gonna take about 10 minutes, 15 minutes to do that. In the manipulating data R lab. Manipulating data in R lab. So Leslie and I are gonna be walking around for the next 5, 10 minutes, going over these things. So we're not using the bike lane data for these. We're using the road and crash data. Again, you need tidyr loaded up if you want to use those tidyr functions, separate and unite.
Oh, is that where they were queried? Oh.
No, that should. It's in Dropbox, so I should have it. I did that for lots.
so whatever the new column name is going to be. In this case, you kind of just want to replace the existing road column with a new version of the road column. So it'll just road equals.
And then, do I take out this part since it was already called in the data set here?
Well, there, yeah, you can remove the crash dot because it knows exactly what is within the
Sorry.
Well, if there's an unfinished command because you see a plus at the end, so if you just hit escape when you're in the console. And just click on here.
Good.
So
There we go.
if you click down here, you see how there's a plus.
So what do we get to?
There's like a
Um,
parentheses or something like
Make
that.
sure that sounds
So
familiar.
if you click down here, you escape.
Okay, so I want to see how these songs on it. I'll just make sure to install it on. So now we're in
Yeah.
Okay.
Just so right quick, it says on the column.
Here, let me take a look at your command.
Okay.
So if you go to
Okay.
Reshaping Variable.
Okay. Okay. I got the code right.
But don't be parentheses around the criteria.
Yep, exactly.
Well, we don't want to end.
So, no, so this is saying replace this variable with whatever. So it's this is the bar. So in this case, we're going to use road. Okay. So road equals. So not in this example, but in the crash data set, it's road equals crash. Yep. Mutate.
Well, there have spaces instead of dashes, so that's good. Okay.
Not in the option, so in the flyer function, we don't. You say road. Use the capitals because we're on redefine this.
Yeah.
Oh, now? Oh, no, that's fine. Okay, that's fine.
All right. All right, so really quickly, right? Everybody should be able to read the data in, right? The functions should be in there as long as you use the internet. Everything should have worked okay. So if you look at the crash data set really quickly, you see it here. You see the road, number of crashes, and the volume of cars in there. In the road data set, it's the road name, which district it is in, and how long that road is. So right now, we're just going to do some fun string manipulations. But later we're going to start doing some merging and joining of these two data sets so you can get, for example, the length of the road with the number of crashes. So, crash 2, we're going to replace hyphens with spaces in crash road, and we are going to call this data set crash 2, and then we're going to table the road variable. Okay, so somebody start me out. So I'm going to put crash first, right? So we're going to say, let's pipe this in. So what am I going to do to change some columns? What verb in dplyr? What function? Mutate. Okay, and I want to replace road, right? So what am I going to do here? So let's do it the piping way. So let's put the variable, and I'm going to pipe it into what? str replace. I want to replace what? Hyphens? With a space in crash road. Okay, so then we want to say, so somebody give me the table command really quickly. Table. Crash 2, or we're going to do crash 2. The road variable, right? Let's table crash road. So we saw interstates had spaces, but US roads had dashes. So what we did was we just took out those hyphens, those dashes, so that we have interstate. It would be interstate space interstate name or US space US road name, rather than hyphens. Right? So nothing happened to Interstate 275 or any of the other ones, but US 40 and US 36, they had spaces rather than dashes. Okay? How many observations are in the crash in the road data set? How much? 110 in what? In both of them. How did you get that? We can look at the environment. That's one way to do it. How do we do it with code? Count crash? That's one way. Say n row. Dim. Okay. Up. Whoops. Accidentally wrote that in as the head. So yeah, no, road only has 5 observations. That seems wrong. Nope. Sorry, that's the data we're working with. Yep. Just those interstates. I don't know why. I forget what. We might have actually reassigned that. Alrighty. Separate the road column into type and number in crash 2. Reassign this to crash 2. So we're going to replace it. So what command are we going to use to separate 2 columns out? Separate. So I'm going to say crash 2 again. Separate. What am I going to put in there? Col is road. Into. So let's look at the column names. Again, these all should be in the key if you are looking at them. So now, there is no variable called road anymore. We split them out in a type and number. And let's look at crash 2.
Can you read it so we can see the whole code?
Yes. So you should be able to see all the code in the key. So if I do jump from something else, but that's yeah. So now it says interstate, so it'll say interstate or US, depending on what this was, and it'll give us the number. But if we didn't do that with the hyphens, if we didn't replace the hyphens before with spaces, it wouldn't have done that correctly for the US roads. Also, let's look at the defaults for separate. So it says this weird thing for separator, right? It says anything that's not alphanumeric, it assumes to be the separator. So it might do some smart separation. In this case, it knew to separate on space. But usually you want to be explicit, and we would put the separator in here and say, I want to separate on spaces. Okay? So it'll try to guess what the separator is, but it's always better, to use So you don't have to have square brackets around this. You can, I believe. Yes. So the only reason, oh, sorry. That command's not running. That command's not running correctly because we removed the column road and reassigned crash. So the brackets would have worked just fine. You don't necessarily need them, but you do need them when the thing you're trying to separate on is special, like the period. So in this case, we can still put the brackets in there and it's totally fine. It says separate specifically on a space. So let's table crash to type. What do you get? So of the crash data we have, 66 of them are on an interstate, 44 of them are on a US road. Okay. If I never did, so let me really quickly. So I'm going to show you. So I'm going to do the same thing. I'm just going to call it crash 3. Where the big difference is I'm not using crash 2. I'm using crash. Move this down a bit. So again, I'm not using crash 2 here. I'm using the original data. Using the original data that had US-40, US-66. And it gave me a little bit of warning. It said too few values, which means you try to separate something out into 2 columns, and when I tried to separate it, it only gave me 1 thing, or fewer than 2. Again, there's nothing special that we put 2 things in here. It could be if there was interstate space, number, space, county or something, you would say type, number, county. It doesn't matter. It doesn't have to be just 2. So let's look at crash 3. Interstate's fine. But because they didn't have any spaces in it, because they were separated by dashes, by hyphens, the US roads didn't separate into 2 columns because they're separated by hyphens, not spaces. All right. Now you said, you know what? I really liked it. I really liked it when things were separated by hyphens. Let's put them back together. So now we have crash 2. So what's the opposite of separate? Unite. And now, what is the new column we want to call? What is the new column name we want to call it? So road hyphen, right? Let's call it road hyphen. And then it says ... which means specify the columns you want to unite together. And in this case, it would be type and number. And the order matters. So just for the sake of argument, I'm going to use number, then type. Now it says 65 underscore interstate. It says, well, it's not exactly right. I wanted it separated by dashes. So again, if you look at the help file for unite, you see, okay, the separator by default is underscore. All we would have to do is change separator into dash. I'm going to switch these order around like we should have. So we want to go, pull this over. I'm going to go to the next line. So it says crash 2, I want to unite. This column is the new name I want to come out. I want to unite the type column and the number column, and I want you to separate them with a dash. And I have to, because I reassigned crash 2, I have to rerun this code up here. Rerun this code here to get our final product. So again, type and number are no more. They've been joined together into road hyphen, and now it's interstate dash or US dash, and then the number. All right, so these are, str functions and paste together can allow you to do all these functions. Can allow you to do all this functionality. The 2 big things it really helps with, these are really common operations, so you don't have to, do mutate and paste and all that kind of stuff, which kind of gets a little bit more clunky of code. And then secondly, it automatically drops the columns that you're joining together, so you don't, and usually that's what you want to do. If you're joining 2 columns together, you don't usually want those original columns plus the join column together. So you don't have to do the mutate command plus select to drop the other things out. It does that in one fell swoop. Which and how many years were data collected? So I'm just going to say table crash to year. So again, if I want to say unique, it'll tell me the unique years. And I can say length on that. Say there were 22 years collected, and they were 1991 to 2012. So that's the data we have here. All right. Sorry if you were typing that. So, so now we got a way to take data from wide to long. We gathered up the columns. We can now, a lot of times when you do gather columns together, right, the column names usually are informative or done in a way that's relevant, right? So visit 1, visit 2, visit 3, visit 4. A lot of times what you want to do is then separate those out, right? So for example, if it was BP underscore 1, BP underscore 2, HR underscore 1, HR underscore 2 for blood pressure measurements and heart rate measurements, for example, and then you shape them down, you'll have BP1, BP2, HR1, HR2, and then you can separate them out. So now it's a column of HR, it's a column of 1s and 2s, and then what we're going to show you is how to take that blood pressure and heart rate measurements and then make them specific columns. Okay? All right. So you gather columns into rows. You spread rows into columns. Okay, so the opposite of gather is spread. Okay, so now we have that long data set where we have all those missing data points, right? So we have let me go back to view that long data set really quickly. Remember, it's got the day, the date, the daily ridership, the orange line, the boardings, and then it has the number. So it's got orange boardings, orange A lightings, purple boardings, purple A lightings, purple average, all that kind of stuff. But not all these lines in the city were started at the same day, right? Not all. So if we go back to the original data, the original data set that we read in. Let me just view it in the viewer to show you what I mean. So this is from Monday to January 10th, 2012. The purple line didn't exist yet. The green line didn't exist yet. The banner line didn't exist yet. The only line that existed was the orange line. When we reshape the data into long, there's still a row out there in this data set for January 11th, 2010 for the purple line data. But it's all missing because it doesn't exist. It didn't matter. It wasn't relevant. That line wasn't there. So now, to condense our data, sorry, I'm jumping around after the lab. So we just say, hey, remove anything that's a date. We can remove anything that's also a number. We could have removed that as well. So we can filter those rows out. Now we have this, we name this data set wide, and now this is the syntax for spreading out columns. So spread the data set, the column that you want to spread out, right? These are the new variable names. So in this case, type, and what you want to fill that data in with. So again, let's go back. We have line, which is orange, purple, green, and banner. Type, which is boardings, A lightings, and average. And number, which is the actual number, the actual numeric that is associated with them. But they mean different things in this column. It's not necessarily appropriate to have this as one column because some of them's boarding, some of them's getting off, some of them's the average. So we want to separate those out. So we say, okay, take the type, make that into different columns, and then I want to fill it in with the number. So now we see we have the different lines, and for this specific day, the 15th of January, we separated it out to A lightings, averages, and boardings. right? So it took that column of type and it made 3 different columns of it based on the unique data. So gather, if we say gather on those 3 columns, it would turn it back into long. Spread, we have to say which column and then what you want to fill it in with, and it spreads it out. Okay. So that's the basic syntax. So what we're going to do, we're going to jump back to the lab. Nope, I don't need to do that. So I'm going to jump back to the lab, and we're going to go through the next few sections on that, which are part 3, which is about spreading. So we're going to talk about the bike data set. So we're going to read that data set in. We're going to do some summarizations and some selection, and then we're going to reshape it using the spread command. So now we're on part 3 of the lab. So we're going to go through parts 8 through 12 for the next 15-20 minutes. Okay, so you have to put, so this is saying I want to separate on how many. Yes. So it's saying I want to separate. So normally, so the brackets on is not necessary. You can just put straight quotes. Yeah. The example we gave is so we could just go. Space is not so small. Suggest if you have like a list of I'm gonna do this in SAS very well. Right? That is like this is I do this every day. I do this 90 times a day. There is
I
so
don't know
much.
where
There
to
is so much.
start,
Yeah.
but I'm going to do statistics tomorrow, right?
Statistics, yeah. So, yeah. So we are going to cover joining for about another 20 minutes after this, and then go over some of that in the lab. It's probably another 40 minutes on this, so about till 4, and then run to plotting, and then we'll probably let me just double check the site. Oops. Yeah, so I think we'll probably, like knitter, we'll probably not touch on because I want to definitely hit statistics and visualization pretty in-depth. It's just a way to write reproducible reports and stuff like that. But again, that's fine, but you can learn that relatively straightforward based on some of that. If you know R, it's just a way to write code around that. Yeah. Mm-hmm.
So there's a main variable, and sometimes there are multiple observations you can gain. We want to sum up all the web links within those groups.
So we want to take an average.
Not an average, but just a sum. Yes.
Rather than collecting.
You can call it multiple link.
So by type, it's not like that, it's by name.
That's at least how.
What does it summarize there? Why does it say summarize?
Because you are summarizing, right? The summary is the total.
reassign it without groups such as right? How does are for that? So insert command override and summarize. Computations are done.
Sorry, just to be clear, in this question, length, there is a variable in the data set named length. Right, so I'm talking about this variable. I'm not talking about the length function or the length command or anything like that. So when I'm saying summarize the group by taking the sum of the length, I mean the sum of that variable using summarize. Take about 3 minutes and we'll go over this. Is it working? Is it up on the website?
I see it, but
Give me 1 second. It's just just give it a minute. It should be up there. It's just there's a lowercase versus uppercase on the key naming. It should be up. All right, so let's go over these. Oh, okay. Alrighty, so reading data in should be pretty straightforward now. Using CSVs, read underscore CSV. Filter out any rows that have missing value in the type column or missing name and reassign the output to bike. So I'm going to use filter. So what am I going to filter on? So what's the command for checking missing? Is.na. But we want them not to be missing. So what am I going to put in here for type? I'm just going to put the variable name. Same thing for name. Right, and again, if I don't put an and sign, it by default will assume I want to do an and operation. Bless you. So it's missing, not missing type, and it's not missing name. Okay? Select only the type, length, and name variables. So we're going to use select because we're selecting columns. Summarize and group the data by name, and take the sum of the length and reassign the length variable. Call this data set sub. So we're going to say sub. We're going to select. What are we going to put in here? Type, length, name. Group by. What are we grouping by? Name. We're going to use the summarize command. We're going to say length equals because we want to reassign it some length. Oh, need to put bike in here, not sub. So for each of the bike names, this is the total length of bike lanes on those streets or drives or whatever. So now we got a name and a length. So reshape the data using spread. This might not make sense because key is no longer, or type is no longer there. Sorry about that. Sorry, this should be type, at least for this question. At least for what we want to do in the next Yeah, because otherwise you can't do that. So we have to use type. It's not a good, necessarily a great example to spread things out, but so here after we did the summarization, if we use name, did the sum, type is gone up here in sub. When I took the here, let me go back. After I group by name and then I summarize, type is gone. Right? So I can't spread the data out by the type. Sorry about that. Yes?
Can you do like name, comma, type? Group by name and then group by type? And then they would both still be in there and it would just be grouped that way?
You can group it that way, yes. But that'll give you something very different.
Okay.
Right? That'll give you the sum. Here, let's see if I can see all of it. Okay, so this has multiple records now for the name. Right? So it will summarize it, and that could be a unique identifier, but that's not necessarily. Well, no. Yeah, let's do it that way. Even though I'm not sure if that would be a good summarization if there were multiple within a name, within a street, multiple lanes with the same type. I don't know if that's the case in this data, but let's say there were. We'd sum over them and we condensed it. So let's spread out this data, and I want to spread out type, the value to be length. Okay. So now, and yes, that is actually what we wanted to do at the end of the day. So now you see, let's view this data. Now you see for the same streets, right? It's changed it so that each different column is the different types. So for example, Alisana has a Sharrow Street, right? Let's see, one of them that has multiple ones. Okay, so Cross Country Boulevard has a bike lane of type bike lane that is 2,000 feet, a bike lane of type Sharrow, which is 1,500 feet, and a bike lane of type signed route, which is 6,700 feet. Okay? So before, these columns were rows in this data in that column type. When we use the spread command, we spread that type out, and what we filled in the cells with was the length variable. Okay? So now we got spreading, gathering, uniting, separating. The last big thing that I think for data manipulation is merging and joining. Okay, so we're going to use two simple data sets here to demonstrate some rules about merging. So it's going to be a baseline data set where it's IDs 1 to 10, some sort of ages, and that's what we have. So if IDs 1 to 10 in the baseline data, we have their age. Okay. Visit is some follow-up data. We only have IDs 1 to 8, right? We have 3 different visits for them, right? So it's rep 183, rep 138. Again, this is just repeating things. I'm making a toy data set up. That's all I'm doing here. And so the big thing is I'm putting in outcomes here. And the difference is this has 10 IDs. We lost 2 of them to follow-up. But all the other data had all the visits, all 3 visits. Right? So we're going to do some merging and see how this behavior happens when we merge, using all the data, some of the data, and different types of joins. So we're going to merge data using dplyr, and there is a merge command in R. I show some of those slides a little bit later, but we're going to use the join commands because they're a lot more explicit and a lot more intuitive, I think. If you do $join on help, it'll talk about all the different joins. This is a great cheat sheet that visually shows you how to, what joins are, how things are going to be in there, but we're going to show you some examples in a minute. So there's an inner join. So it's 2 data sets. right? You can't join like 10 things together in one command. So inner join X and Y, it will only keep rows that match X and Y based on whatever ID variable or identifier you use. Right? By default, it will take the intersection of the column names of X and Y as your unique identifier. So let's say that the data set X has ID, age, gender, and like 10 other variables. And let's say Y has ID, age, gender, and some sort of outcome measures. Then, when you join them, if you don't explicitly say what you're joining on, how you're merging them, it's going to use ID, age, gender to join the intersection of those names. Usually, you're explicit as to what you are joining on. But an inner join says, keep only the records that match. A full join says, keep everything. Every single row of X, every single row of I or Y, the ones that merge, put them in the same row. But if some of the X's don't merge with the Y's, and some of the Y's don't merge with the X's, still keep them in the data set. So this is a full join. And then there are left and right joins, which are essentially the same operation. It just depends on the order you put things. A left join, X and Y, will guarantee you keep every row of X. The left thing in this is X. Okay? So you're saying X is on the left, Y is on the right. I'm putting them in. Things that match up, the information from Y will come in. Things that don't match up on the Y side will be discarded. So what I mean by that is, let's say you had 2 waves of a study. Okay? And study 1, you had IDs 1 to 10, and wave 2, you picked up 2 new IDs, 11 and 12. If you did a left join, records 11 and 12 will be removed from that data set, because we only keep all the records in the X, which is wave 1, which has IDs 1 to 10. Right join is the same operation. It just dictates which data set you keep all the records for. So right join YX, it says keep all the records of Y. Right? This and this are the exact same operation, just switching the arguments around. That's all.
You can only merge 2 data sets
At a time. So you merge 2 of them, merge the next one, and so forth. There is also, which we're not going to cover, an anti-join that says which ones don't match up. So you can say which ones, inner join says these all matched up. Anti-join gives you the ones that didn't match up, if that's what you care about. So inner join, again, baseline data, visit data, we're going to call IJ for inner join. We didn't put any ID variable in there. Again, it's going to say which variables are named to base and visits that are the same. In this case, the only one that was the same was ID. Has to be case sensitive. They have to be the exact name. It joins them, and this is what we get, right? So we have 24 records. So 24 records corresponding to only the 8 IDs that had follow-up data. The 9 and 10, IDs 9 and 10 didn't have follow-up data in the visit data set, so they are removed. They didn't match up completely. Okay? Does this make sense? So it says, we matched on ID, we found IDs here, found IDs here. Which ones were in both? We're going to keep that. Everything else is out. Full join has 2 extra records, 26 versus the 24 we just had. That now keeps 9 and 10, even though they didn't have any follow-up data. So a full join keeps all the data in X and Y. Inner join keeps only things that match up. And again, they have to match up exactly. Right join, so we say RJ is right join, base, and visits. Pretty much we're saying keep every single record in the visits data set, but not the data. Keep every single record in the visits data set, even if it doesn't merge with the base data set based on ID. So here we see again there are 24 observations. 9 and 10 were not there because they are not in the follow-up data set. They're only in the baseline data set. Sorry, oh, sorry. I was gonna say, usually I would go on the left join first. So left join, right? So, sorry, yeah. Oh. Okay, I'm flipping through a lot. So I thought I put the order in: inner join, full join, left join, right join. But this is a left join. So again, every single record, every single identifier, so I'm sorry, not necessarily record, every single record will be kept, but every single identifier in the baseline data set is kept. So IDs 9 and 10 are kept. So that's why we have all the data set. From baseline, that's why 9 and 10 are kept in that data set. Right join, it's the same operation except we're using the visits data set as the one to say, make sure you keep all the IDs in this data set, the one on the right. So in Stata terms, it's master and using, right? So it's just flipping around which one's the master, which one's the using. But right join, I almost never use right join. The way I never think of joining from the right-hand side. I always think of it from the left-hand side. So the left join we talked about before is exactly equal to the right join if you flipped around the arguments. Sorry, this only says identical equals false based on, because you have to resort them. They sort them in a different way. So they will do some sorting based on the data. A full join, make sure you keep everything. So let's say you had IDs 1 to 10 here, or 1 to 10 here, and you were missing ID 8 here, but you had 11 and 12. You'd have all IDs from 1 to 12 in that data set with a full join. Everything is kept from both data sets. So we're going to go to lab in a minute, but I want to draw your attention to the help file because it's relevant. And if you look at the dplyr, join two tables together, you'll note one last thing. Well, one, you specify by. You explicitly say the variable you want to join on. Suffixes. If, for example, you have dataset 1 that has age in it, dataset 2 that also has age in it, and you joined only by ID, right? The variable from dataset 1 will have age.x as in the output of the join. You'll have age.x, age.y. If you have variables that share the same name that were not used in the merging, right? That were not specified as by. I don't believe there's an option to have you update them, for example. So for example, if dataset 1 was some data, dataset 2 was an updated dataset, and you wanted to do some merging on that and have them update, for example, the age for the non-missing values, I don't think you necessarily can do that, but I would just do that saying, those that are missing is.na for age.x, replace it with age.y.
Can you say that last bit just again? So you would just do a reading, is that what you're saying?
So if I joined x and y, and age had some missing values here, and then I got an updated data set that had maybe more records and stuff like that, and maybe some other variables that I needed to merge in, and I merged them together, it would have an age.x and an age.y. So I would either just use the age.y, I would have maybe dropped that other age variable before, but if I wanted to say, there's some data in age.x, I want to replace it with age.y if it's missing over here, I would just use that using mutate or something like that. So I would say, if else, I would use an if else statement to say, if else is.na, age.x. If it's missing, put in age.y.
My concern is that there might be other variables that could be coming in other variables.
So you should not be merging. You should either be dropping them filters or selecting them beforehand, I would say. But if there are hundreds of other ones, and you try join, it will try to join on them, and that's not a bad thing to just do for this, just to look at what the output is, because there is something concerning if you have two data sets and age is a variable here and age is a variable here, and they're not exactly the same. So they should merge fine as long as they're exactly the same without putting explicitly a by. But I'm saying if there are clashes, if there are in X and Y the variables of the same name and you don't put them in the by, it's going to put suffixes on there to those variables. You can change these to be whatever you want, right? Some people don't like that X dot Y.
It'll list them out, or do I have to go look at the dot?
I believe you have to use the dot X. You would just, use it, grab column names and do like a str underscore detect to find those that's the case. Yes. All right. Joining. So yes.
So when you do these merges,
Mhm.
does it tell you do you kind of have to unduplicate before you do that? Does it tell you if it's a one-to-one match or how would you know?
So a one-to-one match. So it will merge unique identifiers, right? So if a unique identifier is one row in one data set and it's multiple rows in the other data set, it's going to do a one-to-many. You don't explicitly say one-to-many, one-to-one. And it won't warn you because I don't think it necessarily should, because that's a lot of times what you want to do. Like you want to replicate, for example, baseline data in a follow-up data set.
Suppose you have multiple of each.
If you have multiple of each, you have to put the unique identifiers in. You should put the unique identifiers in explicitly.
I understand. Say, suppose you have multiple IDs in two data sets and you're merging by ID.
Mhm.
Okay, but you don't realize it. You like to, in other words, is there a way to check?
What do you
Or
mean?
is it giving you a warning that you're merging?
So what do you mean you have multiple IDs?
You have more than one record for each ID
Mm-hmm.
in each data set. So you're merging maybe 2 or 3 in each.
So you're
merging
saying
by ID, and whether you want to or not. In other words, you may not even know. You may not have checked to see that you're not unique.
so the by is not a unique identifier.
Correct.
So I believe it will tell you something is duplicated, but I'm not 100% sure on that. Yeah. But I would. Yeah. So there's no like underscore merge variable, right? Like there is in say or SAS. I don't know exactly. But like that variable is not that great for a lot of reasons. You can replicate that very easily in R. You add a new column that says. You just make a column that says in dataset 1, for example. You merge them, and if it's missing, that means it's not in dataset 2. Or you explicitly use anti-join and see which ones don't match up and see why that's the case. Right? Yes?
Did you go over what semi-join is?
No. Yeah, it's a little bit different. So it's I didn't go. It's used a lot less commonly, I would say. All right, so we're going to go into part 4. Now we're going to take about 10 minutes to kind of go through these. So it should be just 3 questions, just joining, crash, and road. And we're going to go over those results and then move on to visualization. Okay? So all 3 should be up.
Today and tomorrow.
Oh yes, okay. Yes. So I will upload this lecture when it's not done.
Yeah, the other 3
Okay.
So how do you, when you have to do a merge, how do you compare, like if I did a left join and a right join, and wanted to compare the 2 data sets, like were able to see what was different about these
So why would you do that?
So like that's like for calling for the noise merge that they actually changed in the data. So like whenever we add variables or change variables or do merge, we would compare one of the previous data sets to check at the version.
Sorry, maybe give me more. That doesn't make much sense to me.
Sorry.
Yeah.
does the merge, and they use collage name and as2 to arrange them, whatever. The way they think they have the same results, what would they do to actually take their two data sets, which should be identical if they both coded things correctly, and compare to see that they have the same results?
So what do you, yeah, so what is the output of like a normal, you said
So,
row
like-
5, like row
So it would
none of them
be,
equal the same.
so it would be like survey data, that's those are what I'm talking about, so like.
But I'm saying, like, what is the output?
Probably are like, you're like running the frequencies you tell and then.
Yeah.
But I'm saying, like, you
Here's
want to test if they're
more-
identical?
Here's like a
That's
more
easy.
concrete example, so, for one of the projects that I'm working on, we started data collection, in-house, and then our survey operations team was overwhelmed, and so we got a subcontractor who's now
Yeah.
finishing data collection, so I have two data sets that should be identical.
So, yeah, so I guess my question is, what are the measures where you call it? Like, literally, like, they are identical? Every single
Like,
thing. So two
like,
data frames,
well,
you
it
would just say
depends on
equals equals. Equals equals will give you a true for every single cell. They have to be sorted the same.
okay, so if I had my two components, create the merge data set and expect them to be exactly equal,
If they're,
it will tell me a true false, or.
so you would have data set 1, let's say the first example, data set 1, data set 2, data set 3, have parentheses, they're ordered the exact same way, they're the exact same way. You say x equals whatever, and then you say, well, you could say x not equal to y,
Yeah.
and then you take the sum of that, and if that's not 0, there is also an identical function, and all dot equal. That is their general use to just test the sum of the So,
Alright.
does that make sense? So,
Sort of.
but like, if you want like a comprehensive report,
Yeah.
that's a little different. You could do x not equal to y, and then you can do the column sums of that, and that'll give you the number of records where x doesn't equal y by each variable. So like maybe like they did it every time. It's like one variable is going to be one variable. So you can do the column sums of x. Does that make sense?
Yeah.
So the equals equals and backups operators do work for data frames. That is like it doesn't do all the ones. So you can do row sums or cost sums to see things that are. So that's not, I don't think it's not a function that's like these don't match on this variable. It's not the report.
So like one of the things I would check is do they have all the same variables, do all the variables have the same shovels? Response options. Are the handles the same? So those are like,
Yeah, so if you say x equals y, they're not the same size, you're just gonna get 1 for 1. Levels, you can do that, you just say, like, so you say, like, is that character, or is that character, or say, like, is that character, so you grab the levels. So, I don't know if there's a function that's made to do that, but I would just, like, I would make a function that's like, just go on and rotate it. All right, let's go through the first couple. Okay, so we're going to join road and crash and retain only the complete data. And so we're going to specify the by option and then specify, not specify it and see what it says. So I'm going to use the inner join function, right? So again, if I don't specify any by, it's going to print out a little message saying, hey, you didn't specify anything. I'm going to take the intersection with those columns and say by is the thing we want to merge on. But if we specify by itself, road, totally fine, no message. And now we have data. So if I say dim merged, there's 88 observations. If I did n row, I would get 88. But again, if I said n row crash. So there's 110 crashes, but only 88 observations. That's because not all the roads those crashes were on were in the road data set. So for right now, let's try. We didn't go over this, but let's try an anti-join. All those crashes happen to be on US 52. Okay. So pretty much the road US 52. If we look at the road data set, it is not in there. But one thing I need to talk about, these are, okay, so anti-join, if you look at the help, it will show you the things not merged, but it's in a specific way. So it matters which order you do things, kind of like a left join and a right join. So anti-join, the first way I did it, road and crash, it says which things in road are not in crash. And in this case, when I present an anti, when I put that up, US 52. So US 52 is a road in our road data set, but there's no crashes on it. We have no crash information on it. If we do anti this way, I print out anti 2, it's showing us the data in crash that have no data in road. So Interstate 275, we have crash information on it. For example, I say unique anti 2 road. Interstate 275, we have that road in the crash data set, but we don't have it in the road data set. We don't have the volume or the length of that road, actually. Right. Anti-join kind of depends on what you're, similarly to a left and right join, to give you the things that aren't in the merge. So if you don't put a by, it will merge on, as long as they're named the same thing, it will merge on all the variables. If they're identical.
Can you use this function to, like, if you have two data sets that you think are identical, but you're not really sure?
So I didn't mean to do that. Crash. Let's see if I make crash 2. Crash 2. Volume 1 is 20. Let's say. So the exact same data sets. So let me arrange full by year volume, I think. So Sorry, let me sort it first before I do this, so we can at least identify the one that's not there. Crash. Sorry, year, road, volume. And then let's arrange our full so we can see that. Let me see. I'm trying to think of what you're asking because I wouldn't do it this way. So excuse me?
Like instead of modifying the first volume to be 20, what if they actually are identical?
So sorry, yeah, so I merged on these. So what do you? Okay, so we got full.
If you merge crash and crash,
Yep.
that should work.
Yeah, it works, but it doesn't indicate if they're identical or not. Right. So if you're trying to see if something's identical, I would probably just use this. So let's say I modified crash 2. I would just say equals equals, and that'll do pairwise. That'll do testing at every single element, right? So you say, is this equal to something, or in some respects, is something not equal to something else, right? And then maybe something like col sums or row sums on that. So col sums indicates we said, is this equal to that one, and we took the column sums. And it says one of the volumes is different between these two data sets. That being said, if they're different sizes, one, you know they're not identical. And then if you do row sums, you'll see that this one has one record that's different. You can also say all dot equal crash, and that should give you true. Crash and crash 2. It might give you something saying that they're not compatible. Identical equals false. So these are some of the commands you might use. So for some reason crash 2, so let me just do this. So crash 2, for some reason when I reassigned this, it turned it into a double. It actually changed the type, which is something you might want to know. But let me just do it so I ensure that it's still an integer, and let me show you what the output was. So all dot equal might give you something that you want. So rows in X but not in Y1, rows in Y but not in X1. Right, so that can give you, so all dot equal is something that allows you to compare two data sets to see if they're exactly the same. So in this case, we did it where volume stayed as an integer, and it gave us this output. Rows in X but not equals Y equals 1. When we tried all dot equal, if you try identical, it's going to come up as false. And if I accidentally changed the data type of a column, and I try all dot equal, it says incompatible type for column volume. X is integer, Y is numeric. I believe so. Somebody else was asking like, what if there are two factors and they have the same levels? I think all dot equal should tell you that. So let's, for example, let's make crash road factor crash road, right? And let's say crash 2 is equal to crash. If I say crash 2 road is equal to factor crash 2 road, and I specify the levels unique crash 2 road, that's not what I think that's going to be in the wrong. They're in order, man. I just sorted. Yeah. No, that's not going to be right either. I want to sample. Just reshuffle them. That's what I want to do. There we go. If you try all that equal on two exact things, two exact data sets, it'll tell you some oddities there. And if I do this fun thing here, then we got two things, right? It says factors aren't the same. They aren't the same data type, right? Okay, so all dot equal is something that you might be looking for. All right, so how many are observations in the full join? 111. So dim. So let's say nrow full join crash road full join. It doesn't matter which. Well, that was just changed around the factoring and all that kind of stuff. It will still merge. Note. It will give you a warning. It'll treat it as a character. Okay, 111. Do a left join of the road and crash. Order matters here. How many observations? Who's got an answer? 81. 89. Everybody else have 89? So I don't have to write this? That's what I got too. So, note this thing. This instata, right, will not work. Mostly. If like one is a character and one has been turned into a labeled vector, it won't merge those two together. At least I don't believe anymore. Also, things don't need to be sorted before they are merged. Those who've been using stata for very, very long, that has not always been the case. You used to have to sort the one and sort the other, save them, then merge them back in, which was always a fun thing to do. All right, I'll again post everything I'm doing up on here as some scratch work. Let's move on to visualization. So, lastly, merge works in R. It's not a bad function like reshape. It's not terrible. But the other joins are more explicit. They give you a little bit more control. R-bind and C-bind, we showed those very briefly. Those allow you to bind things to your data set. So R-bind, add rows. C-bind, add columns. If you add columns, they have to have the same, have to have a length, the same number of the rows in the data set. Otherwise, it's going to give you a warning. But normally, what you would do is, if you're especially just adding one column or something like that, you would just do the $sign operator. But if you're adding multiple columns, it's still fine to do a merge, just the appropriate one, because binding columns is not always a great idea, especially if you had a vector that you got from a data set and then you reordered your data set. You don't want to just lump it on there. You don't want to just append it on, or put it on the side. Similarly, rbind, you have to have the same data types. You have to have the same number of columns to bind to it. These are good. These are okay operations, but they're a little bit dangerous if you've resorted things or changed things. rbind is similar to append or setting in SAS. But again, I would still use the merge. I would still merge on the things on an operator instead of doing that just to be safe. T can also transpose your data, but not very used. Sorry, it just says but not. But we don't use it that much. A lot of times because you're transposing a data frame doesn't make that it's okay, but it doesn't make that much sense because you're trying to put things of different types into the same column. Again, I gave you some code to show you how to do merge using the merge command in R, but again, we're really covering the join command. So there are some added lecture notes in here. One specifically that I want to note is that if you have a data frame or a matrix and you say is that NA on that, so here I selected from a data set 3 different columns and I say is that NA on that, just like I said data frame 1 is equal to data frame 2, what that will return is a matrix or is a data frame with the same number of rows and columns, just a true if it's true, false otherwise. So in this case, if I say is that NA this, it'll give me true or false, but it'll give me an entire matrix for every single cell. It'll do that operation at every single cell and give me a rectangular format back. So here it will be however many rows we have by 3 columns. So then if we do that, right, so we false, true, then we can use some of our other commands that we learned, col sums, row sums, that kind of stuff, to say row sums of this matrix, or sorry, this data frame is greater than 0, means it has some data that's not missing. So here, not NAMAT is saying, give me a true if it's not missing. You see the first 2 records up there have all NAs, right? And that's why they're false here. Now, if you do the row sums, it says count them up. If it's greater than 0, say it's good, which means it has some data in there. So I'm saying is.NA is not just only good for vectors, it can also be used for data sets. And when you start using these operations with row sums and col sums, you can start getting some summary statistics about missing data in your data sets. All right, I'm not going to cover these. Okay. All right, data viz. Data visualization is interesting because there are 100 different ways to display data. We're going to show some of the most common ones, so line plots, spaghetti plots, histograms. We're not going to show bar charts, or so we're not going to show pie charts, some things like that. We're going to show you a couple quick ways to do it in base, but generally we're going to use ggplot2, which is a graphics plotting library in R, also by Hadley Wickham and RStudio. And so we're going to read in some of this indicator data for mortality. So if we write it in, it'll give you a little bit of a warning saying the first column doesn't have a header. And so it just made that column X1. If you say there's a header row and it doesn't have anything for there, it'll just put X something in there. So what we do, and I think for your homework, we have it, you rename the first column to be country. So I think in the homework we say to name it mort for mortality. We're a little bit more morbid here. We called it death. So death is the data set we read in. The first column is the country. The other columns are for each separate year, the mortality for children. So we rename the first one to be country, and you see that we've reset it there. So we're going to use dplyr, do some filtering. So let's say we only want to plot the data for Sweden. So again, we can take that death data, pipe it in here, get only the Swedish data. I want to remove the country column. So now it has only the data that we had before. So 1760 all the way up to, I think, 2012. And year, I want to say, since we removed that country variable, all the rest of them, all the column names are actually the year that corresponds to this mortality data. So we can just make that into a vector as that numeric. So this is the years from 1750 to 2000, actually 2110 or something like that. So there's some projections out for child mortality. So we can plot the data as that numeric. So what this will do, even though this filter will return one specific row, when we say as that numeric, it'll just turn it into a numeric vector because all the data in there are numbers. And we use this formula syntax, y tilde x with the plot, and by default, it will do points. So, it's a very quick run now. End of the day, plot can take in this formula syntax. It's y tilde x. If you have a data set, you put y tilde x, and then the data set if you're picking off columns from there. And this data set's pretty interesting because it's not like normal data sets. Pretty much every column is a specific year. So we're going to have to do some reshaping to make it a little bit more amenable for plotting. So although we're not going to cover base too much, there are some general graphic parameters that you can set in the plot command that are really useful. So PCH is the point shape. So if you click that link there, it's all the different shapes like stars, diamonds, filled in circles, open circles, all that kind of stuff for plotting. CEX is the size of the scale. So if you say CEX equals 1.5, the points will be bigger. The text is usually bigger. So it's just a scaling factor for making things bigger or smaller. XLab and YLab, these are arguments within the plot function They are labels for the X and Y axes. Main in the plot function is you put a text string in there. That is the title of the plot that's put up top. LWD stands for line width, so it's the width of the line. Col is for color. And CEX has different options for the axis, the labels, the main, so you can scale things differently to make certain things bigger while not making everything bigger. But again, we are going to more or less go over most of this stuff in ggplot2, but we wanted to give you a little exposure to plot in R because that is probably the most commonly used function for plotting. So again, we're plotting the exact same data as we had before, y tilde x. Here we put in ylab equals the number of deaths per family. Main, Sweden, is our main title. Type equals L indicates that we want to plot lines versus points. Okay. So xlim is also a useful parameter. It says these are the limits of x that I want to plot. So let's say even though I passed in data up until the year 2010 or 2110 or something, these projections, let's say I only want to plot data from 1760 to 2012. It's saying those are the limits for my x-axis, so it'll only go from 1760 to 2012. PCH equals 19 means we want some of these points that are colored in. CEX 1.2, I want to make everything a little bit bigger, 20% bigger. Col equals blue, I want the points to be shaded blue. So these are some of the ways you can customize a plot in base R graphics. And you can also use the subset command in the data if you want to use data less than, for example, years less than 2015. You can put it in a logical vector saying, I want to subset this data. It's very similar to filtering in that plot.
Does the order matter at all?
No. As long as they're named. As long as you say argument equals something, it doesn't matter the order you put them in. Good question.
I think I'm still stuck on how you selected Sweden with the filter.
So it's multiple countries. So I just selected country is equal to Sweden.
So the select minus country, is that correct?
Select minus country means it says I don't want that country column anymore in that data set. Right? It just drop that country variable completely, because what I'm going to do is I'm going to take that one Sweden row and I want to turn it into a numeric vector so I can plot it, right? Change it from a data frame, and I don't want that country in there because if I try to make that a numeric, it's going to say it's an NA, and that's not what we want. All right, so that data is fine, and we could do certain things like that for plotting, but normally what we want to do with a data set like that is reshape it. And we're reshaping that again using gather. So we're going to use the tidyr package. I'm not going to talk about really exactly what the code does. We essentially take the year, the deaths, drop the country out so that we have the data in long format. So now we have country, year, and the deaths as one long format. So that's the format we're going to be using. That's the format you should, for the most part, be using with respect to dplyr and a lot of these other plotting functions. And the only thing down here, we changed year to a numeric, because after you gather columns, by default, they are characters. So once the data is long format, we can do something a little bit more straightforward. We can filter the data and then plot deaths on the y-axis, year on the x-axis, and then say, I want to use this subset of data set, but it's in a long format. So we didn't have to do this weird as.numeric, all that kind of stuff. Reshape the data into long, and that's the way we plot it. All right. So ggplot2 just had its 10th anniversary. So this plotting package has been around for about 10 years now. And it is one of the most popular ways to plot functions. So if you were looking at the slides on your computer, you will notice that it doesn't exactly look like this on the projector. This is a problem sometimes projecting some of these plots. There should be grid lines and that kind of stuff in the lecture notes that you're looking at. Okay, so ggplot stands for the grammar of graphics. So it's just a way to build a plot up in a kind of cohesive manner. And one of the functions that is analogous to plot is called qplot. It stands for quick plot. So we have to load in our package. Again, if you don't have this installed, you have to install the package on your machine. And we're going to use qplot. We're going to say that x variable is year. We don't have to put quotes or anything. Y is deaths. And again, the data is Swede long. And by default, you see again, they put things as points by default. It's not a super pretty graph, but it is a relatively quick way to get things up and running, and we'll show how to customize this into something that looks a lot better. Changing axis sizes, changing axis labels, changing point sizes, adding lines or whatever you want, smoothers, all that fun stuff. Okay, qplot is great. The generic way to specify a ggplot is with the ggplot command. One of the reasons why qplot was kind of built is that this isn't always super intuitive off the bat. But I think it's intuitive in some respects. So you say ggplot, you say what data set you're using, and then you specify this thing called aesthetics. So AES, parentheses, is a function, and then you specify x, y, and a whole bunch of other things you want to specify in the plot. So for example, you want to color the points by something. You want the line width to be mapped to some data point, right? You want the size to be relative to the population or something like that. That is what you put in AES. So again, ggplot, you specify the data set, and you have to put this thing called aesthetics in a function. But the one thing you should note, you can assign this to something, okay? This is going to be important because you can make a plot, add something to it, and print both of them out, and then change something, add to it, kind of iteratively, and save the output. So that is one of the big reasons why we teach ggplot over base. So G is an object which you can adapt into multiple plots. So this just sets it up. It just says, this is the data I'm using. And then, when we want to add other things, we just add on layers on top of that. So we can say, I want that as my baseline x and y, let me add points. You're like, well, I don't like that. Let me add lines. Let me add lines and points. So, common aesthetics. X and Y, right? What are you plotting on the x-axis? What are you plotting on the y-axis? Color. Spell it either way. Saying, what do you want to color the points by some other variable? Usually a factor. Yes or no? Size. Do you want the size of the points or size of the object to be proportional to some other variable, like population size? Fill. So you can have a circle where the outer layer is like white and the inner layer is like a different color, so you can fill it with something else. Also, a lot of times for histograms, you fill in the bars based on some other factor. Shape, you can have different shapes for different factors. For example, like you want stars for treatment and circles for not treatment, stuff like that. So we're going to set these things in what's called geomes. So that G that we started at, ggplot, that's just a base. It says, what's my x, what's my y? You haven't added anything to the plot. In order to add something to the plot, you have to say what type of geometry do you want to add. Points, lines, densities, histograms, a smoother, a box plot, a bar, or some sort of type heat map. These are the common ones. Okay? So, for example, so G was this baseline thing we had before. Then we said add a point, add points. Okay? Geome point. That's the way you do it. You literally add things to the plot with the plus. And we can save that thing out as G points, and then we print it. So this is the output. So we said x and y are specified, the data set specified as the Swedish data, right? And then we add the points and we print it out, and this is what actually pops up on our screen. Okay? So the semicolon is only is not, so it's just because we didn't want to print it on like two separate lines so it wouldn't fall off the bottom of the page. The semicolon just says this line is ended, execute the next command. That's all. It's just a stylistic approach so we didn't have things all the way down here.
But that also works for all syntax. If I'm writing the syntax, if I'm writing a new script, I can use that too.
A semicolon?
To
Yeah.
change it.
If you want, you can, yes. If you want, usually I would say stylistically you should probably always go on the next line. I would not necessarily recommend this syntax using two things on the same line. This is only really for the slides. So G, remember G just set the X and the Y. And back here we said, let's add some points. It's like, you know what? This doesn't make sense as points. This makes sense more as a line. So we said G plus geome line. So instead of adding points, we added a line. So that's what it says. It says connect these things by a line. Well, it's like, you know what? I can't really see where the data is. Let's add them both. So order does matter here, right? So order matters in the sense it will add in the order you put things. Because let's say the line was green and the points were black, you'd have black dots on top of a green line. But if you switch the order, you would have black dots where the green line is over them. Let me show you what I mean. All right. And we are going to be jumping into lab. Well, I will do that. I will do that when we jump into lab. I'll grab up that code. So there are other options you can add. So GM Smooth adds a smoother, right? So a low S smoother by I think by default. If you have over 1,000 points, it'll do a different type of smoother just for speed and simplicity. You should see these gray lines here. It estimates some sort of standard error on there. You can turn that off if you'd like. Here, if we want to plot with new data, we have to call ggplot again. So let's say we want to group plots by country using color. So here, I just filtered a couple random countries: United States, UK, Sweden, Afghanistan, Rwanda, from this data set. Remember, it's long, so I can just filter like this. I want to plot the data, sub, X is year, Y is deaths, and now I want you to color it by country. So kind of like GroupBy in some respects, not exactly the same. It's going to group these things together when we do plotting. And now I say G plus geom line. Now it says plot a different line for each country and give me a little legend in the right-hand side. Okay? So guides. Guides are the ggplot2 thing for legends, right? So you say, let's add the line. I don't really need a legend on here. We will show you ways to kind of change that a bit, but take out the legend completely. All right, lab 1. So let's go to part 1 of the lab on visualization. And we're going to probably spend 10 minutes on that. And then I would wanted to go over some of the homework, and then we'll keep going on visualization, statistics, and a little bit of function smart. We're probably not going to get to knitter. That's going to be pushed out because I really want to focus more on visualization and statistics. Knitter was kind of like a bonus if we got to it, but if not, yeah. Knitter was something that if we didn't have time, we were going to push it out otherwise. And I will post the videos online. And pretty much part 1 doesn't start till down here. Everything above it is just walking through the steps that we got to that data set. So just show you some more reshaping and stuff like that. But that is essentially what we had done in the previous lectures. So you're going to be using this AVG, this average data set. So you can just run all the commands up to here to get the data set loaded into memory and then work from here down. So you have to run. So you have to run the loop. Did you run this? So run it again. This one. All vectors. Yep. Run that. So again, if you don't have it, you have to install more stuff. So yeah, so you just have to install it first. Yep. There you go. Just enter. Let's try that. Run those commands again. And now try the command. Yep, you can do it. Yeah, that's fine. Yeah. Yep, perfect. Up there. Come around. There you go. All right, to leave some time to go for the homework, we're going to go over some of these. All right, so got the data loaded up. Remember, if you don't have LooperDate or some of these packages, you have to download them, install them. All right, so let's try qplot, and I'm going to cheat and go to the key. All right, so let's plot the average ridership by date using qplot. So again, qplot, we put x, date, y, the number. Number is the variable we want on the y-axis. Data is the average data, is the data set that's called AVG, and color equals line, so it's colored by different lines. So in the key, you should be able to see the code, and we see that each of these are plotted separately. So this is the number of the average on and offs, so the average ridership for the banner, the green, and the purple by the different dates. The key for visualization. Give me 1 second. It's sorry about that. It's a stupid lowercase versus uppercase letter. GitHub takes a second to refresh. Okay, try it now. Sorry about that. Okay. All right. So again, the big thing is we said color to the variable that was line, and first plot. So sorry, qplot gives you out a ggplot object. So you can just assign this to something we're going to call first plot, right? So now that's an object we can add stuff to. So let's say first plot we really liked. Later we can add stuff to it, change the labels, all that kind of stuff. This is actually saved as an object. And print, we'll just print the thing out. So let's replot 1A where the colors of the points are the name of the route. So banner is blue. So the palette we gave it, so we're just defining a vector of colors, blue, dark green, orange, and purple. Because we already know the order, so it goes banner, green, orange, purple. So we can use scale color manual. This is a function that allows you to do manual coloring of your variables. And the reason it says color, because that's the thing we want to change. If for example we said fill equals line, it'd be scale fill manual. So this word here corresponds to what aesthetic that you're using. So let's go back to this. So now each color corresponds to all the fun things. So now the banners, so now the colors are appropriately corresponding to the given lines. So scale color manual was the function we used to manually color the points. Right? Manually coloring, I mean saying set banner to be blue, green to be dark green, the orange line to be orange, and so on. Otherwise, it uses the default setting. So part 2. Well, it's online, but we're going to talk about the homework now. We are going to be talking about things called facets tomorrow. Facets are fun things that allow you to break things out by variables, where you can color things and do facets and stuff like that. If we wanted to do, so first plot, right? We had all those things. So this, to me, even though it's not very easy to see, this is one of the use cases why I use ggplot over base. Many times what I want to do is x versus y on a scatter plot. I want to color it by something else, and I want to put a smoother on top of it. That is relatively, to me, straightforward in ggplot2. In other languages, or in other, in base R, it's not so straightforward to me. And then we can do it where we say facets wrap. What was the line? So we can do other things where not only do we have the smoothers, even though they're really hard to see, we can have the smoothers and the points, and then we can break them out into different lines. So we will cover this tomorrow with facets, but that's kind of the start basics of ggplot2. So I wanted to go over some of the homework because I know there's a lot of problems with it. Homework 3 is updated, so if you did download it like 2 days ago, it should be much more straightforward, right? So I try to be very explicit, use the rename function in dplyr, for example. Reshape the data using the gather command, right? Read it using TSV, stuff like that. So I do apologize. Homework 2, I did update the Carvana data dictionary because that was a nightmare. So that is a nightmare because that's how people put data in things, right? So that data was kind of fixed with, but kind of not. So it was fixed with text, or with tabs and spaces. So sometimes there are things I won't do necessarily completely in R. It's very rare, and this is a code book, so I reformatted that data in a text editor so that like 4 spaces and tabs were kind of consistent. But yes, that was a nightmare to get in. I apologize for that. So let's look at the key. The key should be up, right? Does that work? Can someone test out this key? Okay, we get down. It downloads something. Good. So the key to the homework should be up. So again, you read the data in using read CSV. I'm reading the formatted Carvana data in there after I reformatted. So So there are ways you can work with that data, but you have to kind of go back to just reading it in line by line into a character string and then doing some parsing on your own. That is not something we've covered. That is not easy. It's not fun. There is a read lines command, and that will literally read it line by line and give you a character vector back. So if, for example, you're like, this data is so unruly, I don't know what to do with it. What was it, Carvana dictionary? It would give you something like this back where you get the raw character vector back where it's /t's or tabs and stuff like that, and you can change tabs to spaces or something like that, so you can do some string stuff. But again, that's a little in the weeds for now. We said use the save command, right? So you save cars and key. We're saving it to kaggle.rda. All right. So again, if we load this data up, cars and key will be loaded when we load the data back in. So what's the range? Again, like min, max, all that kind of stuff. Use range. Range also again is ni.rm equals true. What is the range in the manufacturer's years? How many cars were before 2004? So in this case, we could use table. I just use sum, and if you use percent, and then we want to know the percentage. Oops, sorry, I accidentally sourced the entire thing in there. So the mean number of cars, sorry, there are 11,000 cars that are before 2004. There's 15%, that's 15% of the population. So drop any vehicles that cost less than or equal to $1,500 or missing. How many vehicles are removed? The rest of the questions expect answers based on this. So if you sum up, if the data is less than or equal to $1,500 or it's missing, that'll drop 71 cars out. If you use filter, right? And you took this number of rows, subtracted from the one before, the difference will be 71. So 71 cars are dropped.
So we were supposed to drop the ones that were missing as well?
So if you use filter, that'll do that automatically.
Okay.
But the sum command, I wanted to make sure it definitely summed up the ones that were missing as well. But filter would have done that because this condition wouldn't be true. Right? So how many different vehicles manufacturers makes? So this is length unique or length table over and over again, right? So it's saying get the unique, say how many there are. So this is using summarize and group by again. Which vehicle, make, model, and color has the highest average acquisition cost? Look at vehicle B cost. Paid for the vehicle at the time of purchase. What was the cost? So one way you can do this is you can group it by make, get the mean cost, and then arrange it by descending means. So Lexus was the highest make. If we do the same thing for model. An Escalade two-wheel drive was the highest model. And if we looked at colors, black, I believe, is the highest cost in this data. We show the way to do it base R. I'm not going to go into that. So again, same story for number 7. The only difference is we don't use mean here. We use var for variance. So Lexus has the highest variance. Highlander four-wheel drive V6 has the highest variance for cost. And Maroon, for some reason, is the most variable in price. Okay, here are some basic things. Let's look at the plot of, let's see if when I make my window that small, it doesn't like that. Okay. Well, let's do that. There we go. Okay. So that's what it looks like. Cost versus odometer. Right, not a very lovely plot here. Doesn't seem to be a huge relationship, but there's some huge outliers, some really, young cars that cost a whole bunch of money. So these are probably young cars in the sense they haven't traveled too much. Again, we went over how to do box plots, looking at whether the whether it's bad buy or not. Look at the cost of the car. So it looks like some of the cost of the car. So on the x-axis is it a bad buy? Yes or no. 1 is yes. So it seems like these really high cost cars, it says, are these lemons are these bad buys. So again, the rest of these are either summations or tabulations or some sort of combination on filtering. So sum equal the color of red, and it's less than 30,000 miles, made by GMC, and they're from Texas, are blue or red, using percent and percent or the or symbol, made in Chrysler or Nissan, and are white or similar. So this is just a compound statement. We gotta put parentheses around this, right? You say this percent in Chrysler, and it's white or silver, right? So you have to do some grouping, or you can do some grouping. You don't necessarily have to with certain things, depending on the operation. But here we do explicitly do the groupings with the ends. And again, the last question is exactly the same, just different criteria. Just reiterating the same thing over. All right. So we got some interesting visualizations, but we haven't really gotten too deep into it. We got just your plotting things, plotting some scatter plots. Very last thing I will show you is the thing I was talking about that I would do while you were looking at labs. That if you plot, so this is not too easy to see. This is plotting points and then green lines. So if you look, it's really hard to see, and I can't zoom in for some reason anymore. If you look really close on the points, there is green lines over those points, right? So the line was plotted on top of the points. If I switched up the way, and I said plot a line, and then plot the points, you'll see that they cover. You'll see that the line is in the background. Whatever was plotted first, this thing was plotted on top of it. So the order does matter in some degree. Right, so if we look at this simple point right here, I'll just flip back, and you'll see that there is a wherever my thing is, there are like lines through these points. That's all. So the order kind of matters for visualization purposes. All right, so homework 3 is posted. The lab will be posted. This will be posted by the end of today. So I